Session for today. Noam talking about najaeada. Thank you.
Yeah. So thank you. First of all, I want to thank my co-founder, Christoph Alexander. He was here last year with a really good presentation. I encourage you to see it on YouTube. And also a remarkable physical designer that helped us to work more on the ECO topic, because to be honest, we are more software engineers from the EDA side. He more added some experience as a hardware designer. And I think the title is self-explanatory. najaeada, which is our product, getting closer to an industrial-grade ECO solution with an open source stack. Just a sec. Okay, so Naja and najaeada. So Naja actually started as a project for open source EDA framework that is mainly focusing on post-synthesis netlist. The core language is C++, with a lot of elaboration of really fitting for industrial grade designs, big, across multiple files, hierarchical. So this is also the Go data structure. We support formats of Verilog and Liberty. We also plan to maybe later support left def, but it's still some work that is need to be done. Capabilities, it's mainly cross-boundary analysis to really traverse between hierarchies to extract equal potentials, and also folded editing. We'll maybe touch about a little bit in the next slide. Example applications, it's analysis, ECO, optimization, and things in this direction. And the use model of this generation was more for really regular GitHub project that you git clone, you build, and then you can use the library to create a new C++ binaries. Unfortunately, we felt in some point that it was not really the target audience flavor, let's say it like this. We are more targeting hardware designers, and this became like a really hardcore C++ software engineering. So we got to additional step. We create another abstraction level. We call it najaeada, and this is basically doing two things. First of all, it's another encapsulation of the API that we have in C++. This is, first of all, it's much simpler, and you can focus on hardware design and not in software engineering. And also, you don't need to git clone or do anything. You just pip install najaeada, and all the capabilities that you had in Naja, you have it now in Python. We've also, obviously, the advantage that now you're in Python, so you can enjoy all the massive libraries that you already have there for data science, for AI, for GPU, visualization. So this is also a massive advantage. So the browsing API, again, we try to do something that is really a minimum subset. So first of all, instance, obviously, you traverse the design, extracting different instances, look at them. You have the terminal other instances that can also be aggregated to buses, and also the nets, the same. And also we give you this cross-boundary analysis of equal potential. You go to a terminal on an instance, you can ask for the net, you can also ask for the full equal potential, and it will give you all of it across the design. So for browsing example, you can see it's very convenient. There is a built-in parser where you can load the Verilog, you can iterate over the terms, you can iterate over the child instances. For editing, it's even, I think, a little bit more innovative, because you can read the old design, you can parse the hierarchies, you can analyze them, but when you edit, we really use Naja in the core underneath to create, for example, uniquification. For industrial grade design, which are hierarchical, and you have model with multiple instances, so if you edit them, you cannot just go to the model edit directly, because it will affect all the instantiations. So here, you can edit it, and we, under the hood, will do uniquification for you. Once you dump the new result, it will be uniquified on the new netlist. I will do it very quickly, but for example, one of the more known algorithms is remove lawless logic. It's maybe the most basic algorithm to reduce area. Here, basically, you traverse back all the logic from the observability points, and like that, you can see what kind of logic was not traced or not used, and to clean it. You can later try to write an application like that read the Verilog, read the library, analyze the netlist, deleting the netlist also with uniquification when needed, and then dump it. It will be quite a project to do it in C++. Here it takes you 25 lines of Python, and that's it. After pip install najaeada, no compilation or nothing. So another subject we are now starting to look at is, okay, so this was done. We will later show what some people done with it. But what with verification for this? So in the end, you do changes. How do you verify them? So now we are starting to look on really to do embed verification inside najaeada. So what I mean, we are going to leverage some interchange format you're working on. Actually, we need, I don't see him now, but Rob Taylor, it's actually, yeah, it was mainly his idea to start to look at really interchange format that will encapsulate a lot of data for all this ecosystem. And we are going to use for this verification one property of this format, which is stable indexing. So if we are the one who are doing the editing, okay, and we load and we can initially transform it to najaeif, the interchange format, so then when we edit, we also know the form, the scope that we actually change. We don't need to read them in the end like two different Verilogs that we don't know anything about. And because of the stable indexing, we also can know and detect after we finished, we can detect where is the scope. Because the stable indexing ensures us that everything we didn't touch stay the same. So then we can iterate over the designs, extract exactly only the things that were actually different, and then focus on them on the verification. And this is basically the flow. You input Verilog, input the library, you immediately translate the input to najaeif, then you have the output Verilog, you have the output Naja interchange format, and when you are finished, they are both go to the minimal scope extraction that we show last slide, and then you can choose the verification engine. We are trying to create like a beta version for ourselves. It will hopefully be ready next month, and this project is actually supported by NGI0 and NLNet, so also have to mention that. So the last thing is basically, okay, so what is the use case you can go to with VCO with najaeada? So basically, after we release the library, we are not other designers, we are EDA engineers, and some people came back to us saying actually they are doing ECOs. ECO basically it's engineering change order. It's most of the time in late stages of the design phase. When you want to change something related to timing, to power, to functionality, but you don't want to go from the beginning for all the steps. So this allows you to do this modification a little bit later. And what we got for some people that we didn't even plan to go to this direction is that with the browsing API, with the adding API, and the fact that it's in Python, it's very easy to integrate in different kind of PD flows, it's actually became something that's quite convenient to use for ECO. And when we try to dig a little bit with them and to understand how it became the situation, they explained to us, again, to be honest, I'm not another designer, I didn't do so much ECO, but this is more the feedback from them, so it should be interesting to see later what people think. But that if you have simple ECO, so you can do it with Vim, you don't even need to, even najaeada is over-engineering for this case. If you just to delete one gate somewhere, you can open Vim, you can open the Verilog and delete it. Unfortunately, it's not scalable to any kind of non-trivial changes. Now, when you go to industrial tools, you can perform very elaborate tasks, but unfortunately, you need to have a certain level of familiarity with the tool, with the commands, with the GUI. To be honest, one user that done ECO with it told us, we asked him, why you didn't go to industrial solution? So he told us, it seems too complicated, najaeada looks simpler, so we just gone with najaeada. And that's it. And najaeada is really in the middle of it. It's friendly API, really basic. We really try to minimize the API as much as we can. Again, the parsing is industrial level. We can even load very big designs with multiple files, hierarchical. And as I said also with the Python use, it's basically, you can integrate in almost every script that you can do for PD flows. For the end, just for you to know, so the Vanch that I mentioned earlier, he was nice enough to share an example of how he used ECO with najaeada. So you can later go to his repo. I encourage you to start it and to talk to him if you have more questions. And that's it, guys. Thank you very much.
Thank you. Questions? Peter, throw it. Nice.
So
Yeah.
Is he here this year?
No, he's not here this year,
Oh,
unfortunately.
Oh well. So yeah, I think this looks fantastic. What's the like scale of design this can cope with? Is this like if I've got a 10 million gate instance, is this going to be a problem? Where does this go up to?
10 million? No, it's supposed to be okay. We already look at design in this size, and also both me and Christoph, the person you met last year, we come from the industry for some time, so we are used to even handle billions. So we're trying to develop something in this direction, so for sure millions we can handle.
Millions, billions. Any other question? We are only running over for 7 minutes, considering that we started with 50 minutes. It's a good improvement. Thank you very much. Let's thank the speaker again. Thank you.